Let's look at scientific notation. In scientific notation, and I know you've done scientific notation before, but I want to review it one more time because you're going to need to be able to take answers that you get in kind of different formats from a calculator and be able to transform them into answers that you can use in stats. So scientific notation is just a way of writing very large numbers or very small numbers much easier. And a number in scientific notation is broken down into two parts. There's part A, which are the kind of the significant digits of the scientific notation, the important digits of it. And those will be some number between 1 and 10. Here's what that means. It's going to be like 3.12 or 6.0 or 1.4938. But these are all numbers where the whole number part of it is equal to 1 or less than 10. And then the second part is you're multiplying that value by 10 raised to a power. So basically the format is a times 10 to the n. Now I know you've done this before, so I just want to do one, but then I want to put it in words for you so that we can talk about it. So when I see the 61,200, I know that the first part of it is going to be 6.12 because that's a number between 1 and 10. So it's going to be 6.12, which means my decimal value needs to be between the 6 and the 1. And the decimal originally starts, if there's none, it's implied that it's at the very end of the number. And so I'm going to move, that decimal place has moved from the end of 61,200 to now it's 6.12. So I'm going to count how many places I moved it. And that would be 1, 2, 3, 4. I moved it 4 places. So this would be 6.12 times 10 to the 4th. And that's the same as 61,200. I want to tell you why. What this means is that is 6.12 multiplied by 10 4 times. So if I'm going to write this down and then erase it, but if I take 6.12 and multiply it by 10 one time, I get 61.2. If I multiply it by 10 again, I get 612. If I multiply it by 10 again, I get 6,120. And if I multiply it by 10 again, I'm back at 61,200. So there's multiplying by 10 4 times. That's what that notation means. We can also divide by 10. This next one is a very small number. And so I'm going to mark where I'm going to want, I want this number, the A portion of it, the number that's greater than or equal to 1 and less than 10 would be 3.45. So I know that I want my decimal place right between the 3 and the 4. Okay, so let's count how many places we have to move the original decimal. 1, 2, 3, 4, 5, 6, 7, 8 places. So it's 3.45 times 10, and it's not times 10 to the 8th, it's times 10 to the negative 8th, because what I really have is I'm going to write it in this other color because it's smaller ink, 3.45 divided by 10 8 times. And that's a really small number. If you take 3 and start dividing it by 10 and then dividing that by 10 and then dividing that into 10 pieces and dividing that into 10 pieces, you're getting into really, really, really tiny pieces. So that second one was a very small number. It's times 10 to the negative 8th. Okay, so I'm probably not going to write that out anymore, but 2.57 times 10 to the 7th. I'm going to write 2.5, and then I'm multiplying times 10 to the 7th, so I know it's going to be a larger number, so I'm just going to put some zeros and figure out where this goes. And so what I'm doing now is I'm at 2.5. I need to multiply by 10 to the 7th. That means I'm going to move the decimal 7 times. 1, 2, 3, 4, 5, 6, 7. Right there is where I want the decimal to be. And so when I write that out, I get 2, 5. How many zeros is that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So that would be 2.5 multiplied by 10 7 times. Here's 8.35 divided by 10 6 times. So if I'm dividing by 10, I'm going to have a small number. I'm going to put myself some zeros and put my 8.35. And now I'm going to count them up. I'm going to divide by 10 6 times. So that would be 1, 2, 3, 4, 5, 6. It's going to make a really small number. I have 1, 2, 3, 4, 5 zeros. So 8 point, nope, I'm not going to write it that way. Sorry. I started to write out the wording again, but let's do 0.1, 2, 3, 4, 5 zeros, and then 835. Not 8.35, 835. There's only one decimal point in the number ever, and that one decimal point has been moved to here to represent 8.35 times 10 to the negative 6 in standard notation. Let's put some boxes around these answers. And the last one, this is one you might see on a calculator, and it says 7.25 e negative 4. Or e minus 4 is what it kind of looks like, but it's e negative 4. And what that means, you can translate that to 7.25 times 10 to the negative 4th. That e can translate to times 10 to. And then the exponent would be negative 4. So let's do that one. 7.25 times 10 to the negative 4. I'm going to put some zeros down. It's going to be a small number because I'm dividing by 10 4 times. 7.25. And now I'm going to divide by 10. 1, 2, 3, 4 times. So I have 0.000725. And that's scientific notation. So give that a try and practice, and then you'll check your answers and see how it goes.